Mr. Myers is here, and in this video, this is part 2 of my complex numbers video. So we're looking at complex numbers or imaginary. Remember, we have an imaginary part, and we have a real part for imaginary numbers. This is my funny little comic strip here. Why can't they see me? Probably because you're imaginary, right? Okay, so let's take a look. In this video, really what I'm going to focus on, guys, and I'm going to come real close to the camera here. Really what I'm going to focus on today is going to be using what we call a complex conjugate. Now, we've already used the conjugate once when we did radical simplifying, radicals when they were in the denominator. And an imaginary number, a complex number, works a lot the same way as a radical would in the denominator. We want to clear that out of the denominator. We're going to use a complex conjugate. So we're going to do that for simplifying in this video, and we're also going to use imaginary numbers when we're solving a quadratic equation. Okay, so let's take a look at some of those. All right, so let's move on to the next slide here. And so now we have this, and this should be simplify. Okay, so we're going to simplify this complex number. In order to simplify a complex number that has a complex number in the denominator, we're going to do the same thing we did with radicals, which is to multiply the top and the bottom by a complex conjugate. So this is what the conjugate looks like. 3 minus 2i. Remember, we did that with square roots. In a square root situation, we might have had a square root of 2, and then we would do 3 minus root 2 and 3 minus root 2. This is the same thing, folks. It's just using I instead of a square root. So what we're going to do here is we're going to multiply this guy out. So we're going to get 15 minus 10i. And then remember that we could multiply this whole sucker out, right? We could FOIL the whole thing out. And if we do, we're going to get 9 minus 6i plus 6i. And then negative 2 plus 2, or times 2 is going to be negative 4i squared, right? So watch what happens. These middle terms here, they cancel out, right? So what we could do is we could have saved ourselves a lot of time, and we could have just taken the 3 multiplied by the 3, and then the 2i and the 2i, and multiply those together and not have to worry about those middle ones. So that works if we're using the complex conjugate. All right, so that's going to give us 15 minus 10i over 9. Remember that we get I squared, and I squared is negative 1. So sorry about this, folks, but I've got a fly buzzing around on my head, and it's bugging me, which is what bugs do, right? That's why they're called bugs. 9 plus 4. All right, so I end up with this. 15 minus 10i over 13, okay? So remember, though, that we want this to be in a complex form. And in complex, we have a real and an imaginary part. So I'm going to split this guy up. I'm going to split him up to 15 over 13 minus 10 over 13i. All right, so that's our simplified version. Again, all we're doing is multiplying a complex conjugate. We got the same thing with the opposite sign, the top and the bottom, all right? Let's take a look at another example. And you might want to try this one on your own before I do it, so that way you can get a little practice, because I've eliminated some of the practice problems in this video to kind of make it a shorter video for you. All right, negative 4 plus 3i, negative 4 plus 3i. So I'm going to go ahead and multiply this together, and again, I'm not going to worry about doing the middle terms for the bottom, because I know those are going to cancel out anyway. All right, so I'm going to have here, now this one I do have to do FOIL, right? Got to do FOIL. All right, so I'm going to go ahead and write those out there. So I'm going to have negative 8 plus 6i minus 4i, looks like plus 3i squared, over, now I'm just going to get rid of I'm just going to not deal with those middle terms there, okay? So I'm going to have 16 minus 9i squared. All right, so let's do the math here. We got negative 8. We're going to add like terms for these two guys right here. And we're going to have 2i plus 3. And remember that I squared is negative 1. 16 minus 9, I squared is negative 1. Okay, so we got negative 8 plus 2I minus 3 over 16 plus 9, which is going to give us negative 11 plus 2I over 16 plus 9 is 25. Okay, and again I want to split this up, so negative 16 over 25 plus 2 over 25. And there we go. That's it, okay? So that's how you do that. Remember to make sure that you multiply by the complex conjugate here. You don't have to worry about those middle terms because you know they cancel out. Okay, so this one doesn't have a conjugate. So all we're going to do is multiply by 2I and 2I. Easy, right? That's much easier. What? You're probably saying, Mr. Rice, why did you do that one in the first place? That one's easier than the other ones. Well, we'll do it now. You know. So minus 8I squared over 4I squared. Looks to me like we're going to be able to do some simplifying more than just what we had before, okay? So I'm going to go and just skip that, say plus 8 because I squared is negative 1, okay? And then the bottom is going to be negative 4. Now notice here that a 2 goes into all of these, right? A 2 goes into 6, a 2 goes into 8, and a 2 goes into 4. So I'm going to do this little thing here. I'm going to factor out a 2. And then a 4 here. And then 2 goes into 4 2 times. So I'm going to have negative 3I plus 4 over negative 2. Okay? Oh, you know what? I probably don't want to write it that way. Okay, I'm probably going to want to write it 4 over negative 2, which is negative 2, and negative 3 over negative 2, which is 3 halves. Alright, so this is really the way I want to write it. That's why it may be a little bit more difficult than the one before, because I want to make sure that I write it the correct way, and I do it I make sure that my real part is first, and then my imaginary part is next. Alright, so let's take a look at what I would do if I simplify. Here's some sample problems, practice problems. You can take a look at them later. Come by, ask me if you got them right if you're in my class, and I'll give you the answers for those. Okay, so here's a couple practice problems. I want to kind of cut to the chase on this video, okay? So I don't want to spend a lot of time doing lots of practice. I think you guys can get it. Just get the ones that we really need. Okay, so now what do you have to do if you have to solve an equation? Well, if we have to solve a quadratic, what we're going to do is solve for the x squared part first. So we're going to subtract 18. This is just like if you're solving a linear equation. Okay, and then we're going to multiply or divide by 3 halves, so we're multiplying by 2/3. Okay, we're dealing with a fraction here. And we got x squared is equal to, let's see, 3 goes into 18 6 times. 6 times 2 is 12. All right, now what do I do when I get here? Actually, I should have a negative here. I want to forget my negative. Okay, so it's negative 18. All right, so what do I do now? Now when I get to the end here and I have an x squared, I'm going to take the plus or minus square root of both sides. Remember, if I take a square root of a square, I just have the x by itself, right? So I'm going to have x is equal to the plus or minus square root of negative 12. Now, negative 12 is in the square root, so I can take an I out. That sounds violent. Take an I out. And then we're going to simplify square root 12 to 4 and 3, which is 2 root 3. So I'm going to have 2I root 3. Okay. This is my answer. I'm going to put a little x here. Okay, a little x there. And that's my answer, guys. X equals plus or minus 2I root 3. Okay, last one here today. Actually, I got 2 more. One more example of this. Again, try it as a practice problem. We'll go on here. So we're going to add 54. Both sides. Negative 2x squared equals 54, right? And then we're going to divide by 2. So divide that by negative 2. Sorry, negative 2. So we got x squared equals negative 27, right? 27. Yep. Then I take, what I do, I take the plus or minus square root of both sides. Plus or minus square root of negative 27. So the negative is inside the square root, so we're going to have negative inside the square root. We take out the I, right? So we got plus or minus I root 27. Now 27 is 9 times 3. So 9 times 3 is going to give us a 3 outside of the square root. And we've done these guys before. That's why I'm not going to go over much on the simplifying part, okay? So if you want to know how to do that little simplifying of that square root of 27, go watch my other video on simplifying square roots, okay? So that's what we get for our answer, plus or minus 3i. Now, we have some application problems of imaginary numbers. Believe it or not, imaginary numbers are used in circuits a lot. So here is a formula, voltage equals current times the impedance, all right, which is in ohms. So all we're going to do is we're going to plug in our complex numbers here. So we have a number of volts and some ohms, and we're going to plug them into our formula. Okay, so we have a voltage of this and an impedance here. So we're going to say, what are we looking for? Find the current, okay? So E is my voltage, 10 plus 2J. Okay, J is like I, okay, J is I, like your imaginary number, is equal to my current, which I don't know, so that's I, times the impedance, which is 3 minus 2I, or J. So how do we solve for this? We're going to divide both sides by 3 minus J. So my current is 10 plus 2J over 3 minus 2J. Now, this is an imaginary number here. This 3 minus 2J is imaginary, so we're going to have to simplify that. So we're going to need to multiply by the conjugate, 3 plus 2J. 3 plus 2J. All right, so then we're going to multiply this out, and we're going to have 30 plus 20J plus 6J plus 4J squared all over 9 minus 4J squared. And again, this J is an imaginary number, so it would be like kind of like our I. Okay, so we're going to have 30 minus 4, which is 26, plus 26J over 9 minus 4, which is going to be 5. And this is our answer. Or we can write it as 26 over 5 plus 26 over 5J. And this is going to be in volts. Alright, so there's our answer. There's our application problem. That's all I got for you today. Alright, so simplifying using the complex conjugate. I'll see you later. I'm out of here. Bye.